Let's talk about logarithmic functions. A logarithmic function is just going to be a function of the form log base b of x. Okay? Well, remember that when we dealt with exponential functions, this base here, that's our base, was not allowed to be negative or 0, and it was not allowed to equal 1. So keep that in mind. So let's take a look at what these look like. Let's see here. So here I've got it set up. F of x equals log base b of x. Let's look at a b like b equals 2 here. There we go. If I increase the base, and I see the function kind of flattens out, right? It grows less and less. If I decrease the b towards 1, remember b is not allowed to equal 1, so you see it actually goes away when I get there. If I go less than 1, look at this. It's the same thing but upside down. Right? It kind of flips upside down. Now notice that there are some things that aren't changing here. All right? For one thing, what's the domain of all these functions? What values of x give me an output? Well, any positive value of x. Notice that there's no graph to the left of 0. Graph doesn't live over here. It only lives over here. Why is that? Well, remember, log base b of x is the exponent on b that gives x. Now, b is a positive number, and so if I put any exponent on it, be it positive or negative, I can only get a positive number as an answer. So that means x can only be positive. All right? So that's why you don't see a graph over in the negative region over here. What else is going on with this graph? Well, all these graphs, no matter what b is, they all have an x-intercept right here at 1. Right? The point 1, 0 right there is the x-intercept, and that's true for all of these. Why is that? Well, what that's saying is that log base b of 1 is always equal to 0. Well, that should make sense because 0 is if you use 0 as an exponent, you always get 1. Right? So anything raised to the 0 power is 1, except 0, which is undefined. So that's why the x-intercept is always the point 1, 0. What else are we seeing here? We're seeing that all of these graphs have a vertical asymptote. Notice that they approach the y-axis. They get closer and closer to the y-axis. They never get there, though. If I zoom in, I'll see it never actually gets to the y-axis. But that makes the y-axis a vertical asymptote. The y-axis is the line x equals 0. Let's go ahead and graph y equals log base, let's make that a 2, log base 2 of x. All right, well, let's mark off some values here, 1, 2, 3, 4. And remember that 1, 0 is always an intercept, right? So there's our intercept right there. If I take 2 for x, what's log base 2 of 2? Well, that's the exponent on 2 that gives 2. Well, that's 1. So if I mark off some values here, the exponent on 2 that gives 2 is 1, so I have that value. 3, I don't think I can get a nice value for 3, but if I go to 4, what's log base 2 of 4? What's the exponent on 2 that gives 4? Well, it's 2. 2 squared is 4. So I see we have a value there. Right? And I know that the line x equals 0, the y-axis, is a vertical asymptote. So I can see that the graph looks something like this. So we can get an idea of what the graph looks like without even using any fancy graphing software, just by understanding how to compute some basic logarithms.